Welcome to the lesson on using the material library in Swift Calcs. Swift Calcs is a built-in library of thousands of materials provided courtesy of makeitfrom.com. To use the material library, we drag and drop the material library item from the toolbox onto our worksheet. Alternatively, we can use the keyboard shortcut Material followed by the spacebar while in math mode. When we add the material item, a pop-up will immediately appear asking us to choose our material. Materials are organized into groups by material type, and we can use the search bar to search for materials as well. Once you find a material of interest, you can click on it to load the available properties of this material. Click the Select Material button to add it to your worksheet. Then give the material a name. If we type the name of the material and then press Enter, we will see its full designation, as well as all of the properties that are available for us to use. To use any property in a calculation, after typing the material name, use the colon key to access its properties, and then begin typing the name of the property you wish to utilize. Autocomplete will help you along the way. Note that property names show up in a deep red while you type. Material information can be used in calculations like any other variable. Material data in worksheets is quite powerful, because once you have created all of your calculations, you can see the results for other materials simply by clicking the Change link on the material line and selecting the new material to test. This new material data will be stored in the variable you already created, and the rest of the worksheet will automatically recalculate. As an example, let's load a beam deflection calculation that we've already prepared. You can find this calculation also in the Swift Calcs example listings under the Help menu. In this example, on lines 6 and 7, we have defined the modulus and yield strength for material directly. Instead, I'm going to insert the material box right above line 6. I'll select a carbon steel and insert it into the worksheet. We'll name this material and then update our definition of E to refer to the modulus stored in the steel parameter. Similarly, we'll update the yield strength to also refer to the tensile strength of this material from the material library. After adjusting these variables, the worksheet recalculates with the new values and confirms that our maximum stress is within our yield stress and safety factor. Let us now return to our material listing and change the material from steel to an aluminum. Here, we will pick a 6061 alloy. When I click Select Material, the values for the modulus and the tensile strength are automatically updated to match this new material, and the worksheet recalculates. We can now see that the maximum deflection point is higher, and our maximum stress is now greater than our allowable value. Aluminum would not work in this design without changing some of our parameters. For example, the height of the beam could be changed to 15 inches to add more strength, reducing both deflection and the maximum stress, and returning our maximum stress to within allowable levels. Join us in our next lesson, where we will demonstrate the use of the ideal mixture thermodynamic data in Swift Calcs.